The Utsira Formation is a large saline aquifer off the coast of Norway, at a depth ranging from about 400 to 1400 meters below sea level and reaching a thickness of up to 300 meters. The aquifer extends some 450 kilometers north to south. In our scenario, we will inject CO2 at multiple locations during a period of 60 years and then track the development for another 3,000 years. We begin by specifying boundary conditions, so we will use the panel up here. We can specify completely closed boundaries, semi-open boundaries, and fully open boundaries. Semi-open boundaries means that flow through the boundary is possible, but with significant resistance. Open boundaries means that fluid can flow unhindered through the interface. By default, all boundaries are open, as indicated by this thick green outline of the aquifer. The exact boundary conditions at Utsira are not clear, but we will choose the deep eastern part to be closed and the western part to be a combination of open and semi-open. Boundaries can be set piecewise by choosing Edit Boundaries here and clicking with the mouse inside the aquifer. By clicking at two separate points inside the aquifer, we specify a line, and the part of the boundary closest to this line will be set to the boundary condition currently active in this panel. So we now go ahead and specify the boundary conditions of our scenario. We will now specify the injection sites. We do so by activating the Select Well Sites option and placing the wells by clicking with the mouse inside the aquifer. We will place 3 wells down here and 1 up here. Each well will be assigned a line in the well table over here. If we place a well by mistake, we can remove it by clicking the X on the corresponding line of the well table. We specify the annual injection rates, measured in megatons of CO2 for each well. We will set them to 10 megatons per year for all of the wells. We now move on to specifying the time parameters. In this panel, we see that the injection time is set to 50 years and the migration time is set to 3,000 years. We change the injection time to 60 years. As the annual total CO2 injected is 40 megatons, the final amount of injected CO2 will amount to 2,400 megatons. We can also change the number of simulation time steps for the injection and migration periods. We'll leave them at 10 time steps for the injection period and 30 time steps for the migration period. Additional physical effects can be included at the panel down here. If capillary fringe is active, capillary forces between CO2 and brine will be modeled. Otherwise, a sharp interface between the two phases will be assumed. Subscale trapping emulates additional structural trapping below the cap rock in pockets too small to be represented by the simulation grid. If we activate the Use Dissolution option, the dissolution of CO2 into brine will be modeled. For this example, we activate the subscale trapping option and leave the others off. We have now specified everything necessary to run a simulation. We can now launch it by clicking this green button.